Good day to you, wherever you might be seeing me or hearing me. The topic before us today is light appears to travel in straight lines. Light appears to travel in straight line, or straight line, so to say. When we are talking about travels, we mean changing position from one place to another. You may decide you want to travel to leave your base to another place, maybe to greet a friend, to greet family members. So the same thing happens to light. Light travels in straight lines. And you know what straight lines means. When you use a ruler, and make it to rule a line, so you can see it's traveled to be in a straight form. So that is what I want to explain or to teach you today, that light appears to travel in straight lines. Let's go to the introduction. Now let's look at this intro, that is the introduction to the topic. Light always appears to travel in straight lines. It is believed that light always appears to travel in straight lines. Another one is examples: touch beam or sunlight through a window. Touch beam or sunlight through a window is also an example that light travel on a straight line. Then this explains shadows and other light effects. On this topic, we will look at why do we have shadows, how does shadows come about, what makes a shadow to form. That is one of the things we are going to see as this lesson goes by. What is light? By the definition, before you can say light travels in a straight line, or on a straight line, so to say, what is the definition of light? Light is a form of energy. It helps us to see objects around us. It travels very fast, mostly in straight paths. Like I said the other time, you can see light is a form of energy. How is light a form of energy? Light is a form of energy because in science we define energy as the ability to do work. So you can see the sun from up the sky. Look at the distance the sun has to travel before reaching us here on earth. So it has covered a distance. Okay, so it has done much work to travel down. So light is a form of energy because it helps us to see objects around us. It travels very fast, mostly in straight lines. You can see when the sun shines, if you look at the rays of light, the traces, you can see that they are very straight. If you have taken notice before, you see that the traces of the light is very straight. So that is from sunlight. And during the day, when the sun shines, you can see objects around you. You can play with your friends, you can do anything. But when the sun sets in the night, then everybody will go to bed to sleep. But I'm explaining to you, don't forget about the topic, that light appears to travel on a straight line. And I'm giving you the definition of light first, that light is a form of energy which helps us to see objects around us, and it travels very fast, mostly in straight paths. Let's look at light travels in straight lines. How do we know? How can we explain this? Light does not bend on its own. I think I made mention of a ray of light. When the sun shines, then we can see that the rays, that is, when you dim your eyes, or your eyes is maybe 75% close, so you see and look at a sun, you see the rays, how it travel in a straight line. So light does not bend on its own. It moves directly from one point to another. This creates shadows and beams of light, so that light travels on a straight line. So anything that might want to object or obstruct the straight path of which light is traveling, that result in shadows, which I will still see as the lesson goes by. Let's look at practical example. Now, I was trying to tell you, and I'm still telling you, that light travels in a straight line. So let's look at practical example to confirm that light travels in a straight line. You can see torchlight. See the picture. When the torchlight is put on, see how the light travels. Can you see? You know, it's not traveling in circular form. It's not traveling in curved or zigzag manner, but rather traveling on a straight line. You can see. So when you shine a torch, the beam goes straight ahead. This shows that lights move in a straight path. So a practical example. Now I'm trying to explain to you that light always travel in a straight line. I'm giving a practical example of which I say torchlight, and you can see the picture. Let's look at another one. I don't know if you have noticed this before. Early in the morning, when you wake up and you open your window, as you can see this, you can see practical example too. Sunlight through a window. Maybe early in the morning, you just open your window and you can see the rays of light. Even from the picture, look at the picture you are seeing on the screen. What do you see? You can see that the sunlight is traveling on a straight line. As you can see, the light is traveling on a straight line. See the races. You know, I was explaining that when you dim your eyes out to close to 75%, then you see the rays of light. So these are the examples of rays of light. You can see when the window is being opened down, and you can see how the rays of the sunlight is coming into the room. So this another sunlight through a window is another good example to demonstrate that light travels in a straight line. Then let's look at another one to demonstrate that light travel on a straight line. After looking at the window, the sun through the window, this is another good example of that light travel through a straight line. You can see number 3, practical example 3. We call this one pinhole camera. Pinhole camera, a simple camera that works with a tiny hole. You can see the camera. Even with the camera we use to take pictures, it has a very tiny hole. So the hole is in form of a needle. You know, when you use a needle, a needle is very tiny. When you use a needle to punch something, you see how tiny the circle that is being formed looks like. So that's why you call it pinhole camera. A simple camera that works with a tiny hole. As you can see from the picture, you can see the tiny hole. You can see it. So you can see the tiny hole. This is what I'm trying to say. Can you see the tiny hole here? Okay, the tiny hole. Look at the object. When a light travels, can you see how the light is straight? Then it travels on the object, and the object will appear inverted inside the camera. So a simple camera that works with a tiny hole, it forms an image because light travels straight through the hole. Light travels straight through the hole. So when you place the pinhole camera, so a light, when this is a film inside the camera, a film, so the object forms. The object is able to form as a result of light. If this pinhole camera is being used in the dark, there won't be any trace of light. So any image will not form. And that is why most especially in the night, if you want to take a picture in the night, you put on the flash light in the night to capture the image. You have to switch on your what? Flashlight. Without the flashlight, any image will not form. Don't forget what I'm trying to explain. I'm trying to explain the fact that light travels through a straight line, and I am trying to give you examples, practical examples, to demonstrate to us that light travels through a straight line. I talk about the torchlight. You can see that when you flash the torchlight, it will travel in a straight line. Then I gave you another example talking about sunlight, that when you early in the morning just open your window, then you see that you see the light very shining, and it will travel, the rays will travel through your room. I believe you must have noticed this before. That is another practical example to tell you scientifically proved that light travel through a straight line. Then another practical example 3 is the pinhole camera. Pinhole camera. What do I mean by pinhole camera? The hole is very tiny, very small, so that makes it to be called pinhole. You can see very tiny, very tiny. Though if it is big, it will still form the object, but it may not be as good as when you have the hole very tiny. You can see the box. Practically, you can demonstrate this on your own, and you discover what I'm telling you. So that is another evidence that light travels in a straight line. Then the other time I was talking about shadow. Picture there, look at the picture here. You can see as the light shines, you can see that the light is coming in a straight line. And look at the picture again. You can see the image of a man. You can see the image of a man that is trying to obstruct the travel of the light from straight line. You can see that the image is formed. So shadow or shadows, they are also examples of how light travel in a straight line. Let me read to us what is here. So shadows form because light cannot bend. You can see shadows form because light cannot bend around object. Look at this man. Instead of the light to bend across, that is why the shadow forms, because light cannot travel around the object. It cannot bend. So shadows form because light cannot bend around objects. The shape of the shadow matches the object. You can see. Let me read again so you can understand what I'm trying to say. Shadows form because light cannot bend around objects. The shape of the shadow matches the object. So don't forget what I'm trying to explain to you in this video. I'm explaining that light travels on a straight line. And what in science, we try to get some evidences. That is why science do a lot of practicals to demonstrate what they are trying to say. Okay, so I think with the practical examples I'm giving out, you can see that indeed light travels in a straight line. Let's look at another to demonstrate. We have laser pointer. You can see the laser pointer. See, can you see? Traveling straight. So most of these laser pointer, they are used in stadiums, football stadiums and the likes, especially in the night. You will see all these mood lights, everything. The way they travel, you can see they will be rotating these different kinds, colors and styles. So it's another evidence to prove and to show us that light travels in a straight line. Laser light forms a straight line from the source to the wall. This is a clear proof that light travels in a straight line. Let's also look at some other things. Let's look at this question. Why is this important to study the straight travel of light? No, we want to look at, okay, what we may be saying, okay, why is light travel in a straight line? Why must we study it again? Why, science, they are so rich in knowledge of which to examine, to practicalize, and to carry out research on many things that we don't know. Now we are looking at why is this important to study the straight travel of light. Number one, to explain how shadows are formed. Some will be saying, how is shadow formed? So through the study of how light travel in a straight line, we are able to study how shadows are formed. That is number one of why we are trying to study the movement of light in a straight line. Another one, which is point number two, it helps us to understand how cameras, mirrors, and lenses work. While we study how light travels in a straight line, point number two is that it helps us to understand how cameras, with the explanation I've given now. When I explained what we call pinhole camera. Okay, good. I explained pinhole camera. So it is as a result that light travels in a straight line that we're able to explain the functionality or the working mechanism okay, let me put this way in a simple grammar, that light travel in a straight line, that is one of the things that help us to know how camera is working. Okay, the mirrors too. When you look at the mirror in front of you, if you hold the mirror and you look at yourself, you'll be able to see yourself in the mirror, because when light strikes on the mirror, so it is the reflection of the mirror that is making you to see yourself again. Okay, when you look at it, that is why if you look at the mirror in the dark at night, you will not see yourself, because there is no light. Light is not traveling. So but during the day, when you look at the mirror, you can see yourself, how beautiful you are, because there is reflection of light on the mirror. Then another thing we want to know is that why we study light traveling in a straight line is it shows how we can see objects. It shows how we can see objects. So don't forget that why do we have to study the traveling of light in a straight line? I've given you 3 points. So we have more points, but let me just limit ourselves to these 3 for now. Okay, let's also look at key point to remember. With what I've just said in this video, with my explanation, what are the things we need to remember? What are the things you need to remember? Number one thing that you need to remember is light is a form of energy. That is number one thing you need to remember. Light is a form of energy. Another thing is light always travels in a straight lines. Get that fact, that light always travels in a straight line. Another thing is that shadows prove that light travels in a straight line. I think I explained that. Shadows prove that light travels in a straight line. Then devices like pinhole cameras demonstrate this. Pinhole camera to also demonstrate how light travel in a straight line. So don't forget the topic that we've done for today. Don't forget the topic is light appears to travel in straight lines, and I'm able to define what is light and practical ways to demonstrate that light travel in a straight line. One of which is what? Good. Torchlight, laser pointer, how shadow is formed when you open your window, how sunlight early in the morning travels through the window to your room. So I believe you are I've been able to explain to you and to convince you that indeed light travel in a straight line. Please, we meet again in the continuation of the topic that light appears to travel in straight lines. Before then, I will say bye for now. Thank you.